Now let's look at part 3 of this video where we are looking at series and parallel connection. This time we want to identify series and parallel connections so that we will be able to know the total resistance within a circuit. Now we have said for two things to be in series, same current should pass through them, and things to be in parallel, the same voltage should be across them. But we said it was difficult to find that the same voltage is across resistors. So we'll go around the two resistors to find out whether they are in parallel or not. Watch part 1 and part 2 of this video so that you understand what series connection is and what parallel connection is. So with that our understanding, let's see how we can find total resistance of simple circuits. Let's start with a simple circuit like this. Now, as I indicated, most times it's difficult to know whether things are in series or parallel in the middle of circuit. So it's good to start from the ends of circuit. Like for instance, we check 1 and 2 whether they are in series. You realize that the same current does not pass through them. So 1 is not in series with 2. Neither is 1 and 2 in parallel, because when we go around, we meet an element. Watch part 1 and part 2 and you understand what I mean by this. So 1 and 2 are not in parallel. But let's look at 2 and 3. Realize that when you go around them, you don't see any other elements. So 2 and 3 are in parallel. So I'm going to do 2 times 3 and 2 plus 3. And this is going to give me 6 over 5. And if you remember in the previous videos, I stated that when two things are in parallel and you put the answer together, you have to clean one of the resistors and put the answer on 1. So now I put 2 and 3 together. I want to put the answer where the 2 is. You can put it where the 3 is. 6 on 5, and here is 1. Now realize that after identifying 2 and 3 in parallel, the rest of the circuit left is this. And from this circuit, I can easily see that 1 and 6 are in parallel. So the next thing is I have to put 1 and 6 over 5 in parallel. And this gives me 11 over 5. And this becomes the total resistance within this entire circuit. So simply, this is how to find things in series. Now, let's look at another simple circuit like this. Let's say I have this circuit. You should not be scared with any circuit. All that you need to do is to use the criteria to know whether they are in series or they are in parallel. Now, let's find out which and which can we see are in series or parallel. As I said, always start from the ends of the circuit. So if I start from the ends of the circuit, I realized that 4 and 6, are they in series? No, because the current that passes here, when it gets here, it will split. But let's check parallel. If I go around, I don't see any other element. 4 and 6 are in parallel, right? So I'll do 4 times 6 over 4 plus 6. And that will give me 24 on 10. And that's the same as 12 on 5. Now what I'm going to do is I'm going to redraw the circuit, and I'm going to leave the answer on 1. And this time I want to leave the answer here. So I want to clean this one. Don't forget that when they are in parallel, you totally clean 1 and put the answer on 1. So here is 12 on 5, here is 2, and here is 3. Now what can you see about 12 over 5 and 2? We can easily see that they are in series, right? So 2 plus 12 on 5. This gives me 22 on 5. Right? Then I'll come back and redraw the circuit and see what will happen next. So here I want to put the answer here. You can put it on any of them. Notice they are in series, so I close the other one. So here is 22 on 5, and here is 3. Now what can I say about 3 and 22 on 5? They are in parallel. They are not in series, but the current that comes here will split. But when I go around, no element. So I'll do 3 times 22 on 5 over 3 plus 22 on 5, and my answer will be 66 on 37, which will be 1.78. I always want you to leave your answers in fraction It's just your final answer. You can write in decimal. So basically, this is how to find total resistance within a simple circuit. Let's look at another simple circuit. Let's say I have this, and I want to know the total resistance within the circuit. So let's say here is 2, here is 2, and here is 1, and here is 20 volts. And I want to know the total resistance within the circuit. Realize in the middle will not help me. 1 and 2 are not in series. 1 and 2 are also not in parallel. I stated that the fact that it's not in series doesn't mean it will automatically change to parallel. You have to use the two criteria to check. But let's look at 2 and 2. When I go around 2 and 2, I don't meet any other element, so they are in parallel. So I'll say 2 times 2 over 2 plus 2, and I'll get 1 ohm. Now I'm going to clean one of them, and I want to clean the one on the left and put the answer here, 1, and here is 1. Now what can you say about this 1 and 1? They are not in parallel, but when I go around, I meet an element. But the current that passes through this one, the same passes through this one. So they are in series, 1 plus 1, and I'll get 2 ohms. This will become the total resistance. So simply by checking which one is in series, which one is in parallel, you are easily able to find the total resistance within the circuit. Now, let's look at another example. Let's say I have this example where this is like this, and then you have this. Let's say this is 1 ohm, this is 2 ohm, you have 6 here, 6 ohms here, you have 2 ohms here, 4 ohms, and let's say here is 8 ohms, and here is 19 volts. And you want to know the total resistance within the circuit. First, you have to start identifying which ones are in series, which ones are in parallel. Don't start from the middle of the circuit. Realize 4 and 6 are not in parallel. You go around, you pass through these two. You realize that 8 and 2, they are not in series because the current that passes here, when it gets here, it splits. So 8 and 2 are not in series. So start from the end of the circuit. You realize that 1 and 2, what can you say? The same current pass through them. They are in series. So I'll do 1 plus 2 and get 3. And you come, you redraw the entire circuit again, right? And make sure that you put the answer on 1. So now I want to put the answer here. So I want to put 3 here. Realize I've closed here. This is 6, this is 2, this is 4, and this is 8 and 19 volts. Now, step by step, I want to know this 3 and this 6, what are they? Are they in series? No. Are they in parallel? Yes, because when I go around, no other element. So I'm going to do 3 times 6 over 3 plus 6. And this will give me 2 ohms. So now I'm going to redraw the circuit, and it's now going to be like this. So step by step, you keep on redrawing the circuit as you go forward. So realize that I put them together, and I want to put the answer on 1. Here is 8, here is 4, here is 2. And notice that I put 3 and 6 together. I can put the answer on this or on this. I want to come and put the answer here. So the 2 is going to be here. Now, what can you say about these 2 and these 2? They are in series. Same current is passing through them. 2 plus 2 will give me 4. I come and redraw the circuit. Don't worry about redrawing. It's just a first step to understand the course very well. Just keep on redrawing. So 2 and 2 are in series. So put them together, you get 4. Now, what can you say about this 4 and 4? Are they in series? No. But are they in parallel? Yes. So I will do 4 times 4 over 4 plus 4, and I'll get 2 ohms. And I'll come and redraw the circuit again. Don't worry about redrawing. With time, when you fully understand, you can stop redrawing and always know what to do. So now let's see here. Realize that I can put the answer here or there. So here I want to put it here, and this is 8, this is 19 volts. Now what can you say about these 2 and this 8? They are in series. So you just do 8 plus 2, and this is 10 ohms. And this becomes the total resistance within the circuit. So have you seen, with step by step redrawing the circuit, we are able to put all the resistors together. But one thing I want you to be able to do is that with time, you should be able to use your own eye to clean and put the answer on 1. So with time, as you watch this video, you watch it over again and again, you realize that you know how to redraw the circuit and redraw the circuit. But with time, you should be able to see that 1 and 2 are in series. So I'll put the answer, I'll get 3, I'll put the answer on 1. And in my mind, I have cleaned this one and the answer is here, right? Then the 3 and this 6, I realize they are in parallel. So I'll get 2. And the 2, in my mind, I've cleaned this entire place and the answer is only here, 2. Then because I've cleaned this entire place, I realize this and this are in series. In my mind, I can easily see they are in series, and then that will be 4. Then when the 4, I realize that I'll go and put the answer, this 4, I'll come and put it here and clean and put and close up this place. I'll close up this place, and then I'm going to put the answer on 1, right? And as you keep on doing that, you realize that, and this one will be 4, then 4 and 4, I realize they are in parallel. Then I get the answer to be 2, and in my mind, I've cleaned this entire place, and it's left with the 2, and the 2 and the 8 are going to be in C. So with time, you should be able to use your eye to clean. I realize, I always say that in an examination sake, just try to redraw to make things easy for yourself and make sure you are doing the right thing. So let's see a simple example, and here we'll try and redraw, and later realize that we can easily use our eye to solve the problem. Let's look at this example. Now with this example, you realize that, as I said, don't start from the ends of the middle of the circuit, because you will not easily identify things in series and things in parallel, right? Good. Now let's look at, so we don't start from the middle. You can either start from this end or this end, any of them, and you go step by step. Let's look at this 6 and this 3. What are they? They are in parallel. So I'll do 6 times 3 is plus 3. Then I can be doing end by end. And here 5 and 3, what are they? They are in series. I'll get 8. So I want to redraw now. I want to put 8 here. I've cleaned and closed 1. This is like this. This is like this. And I have this here, and here too, I want to put the answer on 1, and the answer is 2, right? This is 2. And here was 5 plus 3, and that was 8. That's what I have here. Now, what can I say about these 2 and these 2? They are in series, right? So I do 2 plus 2, I'll get 4. Let me also come to the end here. What can I say about this 8 and 8? They are in parallel. I do 8 times 8 over 8 plus 8, and I get 4, right? So I'll come and redraw the circuit and see that this is going to be 4. This is also 4. And then here is 10. So you realize this 8 and 8 are in parallel, I put the answer on 1. This and this in series, I put the answer on 1. Right? So now what can you say about this 4 and this 4? Go around, they don't see any other, they are in parallel. 4 times 4 over 4 plus 4. And you are going to get 2 ohms. So let me fix this time, let me come and fix the answer on this to show that anywhere you fix the answer, you are still going to get the same answer. So I clean this 4, totally clean, and put the answer on 1. What can you say about 2 and 10? 2 and 10 are in series, right? So you do 2 plus 10, and we are good to go. And this brings us to the end of finding total resistance by knowing which ones are in series and parallel. And you see, with your eye, here you could have said this and this in parallel, then with your eye, you have cleaned this place, right? Then the answer is 2. The 2 and 2, you realize they will be in series. After you short here and put the answer on 1, this and this are in series. Short here, put the answer on 1. This and this are in parallel. With your eye, you can see they are in parallel. After you know your answer is going to be in parallel with the one here, and it will be in series. So with time, you should be able to use your eye to know things in series and parallel. Just solve more examples, and you can put your questions in the comment section, and we'll address if you want us to solve more examples in terms of things in series and parallel, and you can bring some circuits and we'll analyze together. Thank you very much, and see you in the next class. Bye bye.